In this video, we are going to talk about solving rational equations. So rational equations are just equations that have rational functions within them, which means that you're going to have variables in the denominator. So we can take a look at a couple examples here. So you end up with denominators that have variables in them. So there's going to be some different ways to solve these. When you have ones like this that have three or more terms, so three or more chunks to them, those ones we're going to talk about doing multiplying by a least common denominator so that we can cancel out the denominators. In ones like this where it's just 2, we're going to just do cross multiplication like you're used to when solving proportions. The big thing to also remember when you're doing rational equations is that you do have a restricted domain, okay? So you do have potentially bad domain values, so you want to look for extraneous solutions. So we're going to have to make sure every time that we check to decide if the solution that we got forces the denominator to be 0, in which case we cross it off and call it extraneous. So let's take a look at this first example. This just has two fractions set equal to each other, so we'll just do cross multiplication. So we'll multiply that x plus 7 up to the top on the left, and then the x plus 3 up to the top on the right. Distribute the 2. Distribute the 7. Okay, and then just solve. So we can subtract 2x from both sides. To get those together, then we can subtract 21 from both sides to get -7 equals 5x. Divide by 5, so you get -7/5 as your answer. And when you take a look at that, just check to see if that's going to make the denominator 0. And the only two possible answers that will make the denominator 0 here are -3 and 7. That's not one of them. So then that would be our solution. Next one, this one has 3 terms to it. So we're going to actually multiply by the least common denominator to just get rid of the denominators. So this one doesn't have a denominator written, so just remember that the denominator here is a 1. And then these two have the exact same denominator, so that's going to be our least common multiple. So we will just multiply both sides by x plus 8. So now you're going to multiply this into each thing. So I'm just going to rewrite down this polynomial here with a little bit of space, so that you can see this x plus 8 getting multiplied into everything. So what you're going to do is take this polynomial here, okay, so this x plus 8, and multiply it into every term. So it's going to get multiplied by the x. It's going to get multiplied by the x plus 3 over x plus 8 term, and it's going to get multiplied to the 5 over x plus 8. So then this x plus 8 will cancel here, and it will cancel here. So now we have no denominators left, which was the goal. So now you're going to take the leftovers, so what's left over on the top, okay, and I'm just going to write it down so that you can see it. So we're just left with the x plus 3 here, and then we're just left with the 5 there after everything cancels out. So now you'll just want to distribute and simplify. So we're going to distribute the x in, so we'll get x squared plus 8x. Don't forget that there's a -1 here, so I had left the parentheses here because this minus needs to get distributed in. So we're going to have to distribute that -1 into both of these. So we'll get -x minus 3, and then equals 5. So now we want to combine our like terms, so we'll have x squared plus 7x minus 3 equals 5. And we have a quadratic, so we're going to want to get everything to one side of the equation so that we can factor, hopefully, otherwise use quadratic formula. So subtract 5 over, so we get -8 on this side, and then equals 0. Then you're going to factor this. So the factors of -8 that add to +7 are going to be +8 and -1. Then we will separate these out and solve. So then subtract 8 from both sides, you get x equals -8, add 1 to both sides, and you get x equals 1. So those are the two solutions that we just came up with, and now we just need to check for extraneous solutions. So we'll go back to the original problem. Okay, so we'll take these solutions that we got with us. Okay, and then we look and see if any of those make this denominator 0. Okay, so when we plug either of these in, does it make the denominator 0? And yes, x equals -8 would make that denominator 0, so we'll cross that one off. That is extraneous, so the only solution to this is x equals 1. Next problem is back to just two fractions that equal to each other, so we can cross multiply here. So we'll do x plus 2 times x minus 2 on the left, and we'll do -3 times x on the right. So we'll want to multiply this out and expand it. So this is a difference of squares, so that will multiply out to x squared. A minus 2x and a plus 2x is 0, and then 2 and -2 is -4, and then equals -3x. So we have a quadratic again, so we're going to want to get everything over to one side, so we're going to want to add 3x to both sides here. So when we add the 3x over, we'll get a plus 3x here, and we still have the -4, and then equals 0. So I just did this, added 3x to both sides. None of those were like terms. So then you want to factor this, if it will factor, and it does. So what are the factors of -4 that add to +3? So that's a +4 and a -1. So then you can split this up and solve. So we get x plus 4 equals 0 and x minus 1 equals 0. Subtract 4 from both sides. Add 1 to both sides. And these are your two solutions that you need to check if they make the denominator 0. So you have two different bottoms this time, so check it in this one. So do either of those make this 0? No. Do either of them make this 0? No. So both of them are solutions. Okay, then this one has 3 terms again, or 3 chunks to it, so we're going to need to multiply by the least common denominator here. So we actually want to factor this one to see if this is in it, okay? So let's factor this. So what are the factors of +20 that add to -9? So this is x minus 5 and x minus 4. So that factors. So now we already have one of them here. So we want to be able to see those factors for when we multiply by the least common denominator. So this denominator has a 1 in it. So what do we see in these other denominators that this one doesn't have? Well, this one doesn't have an x minus 5. And it also doesn't have an x minus 4. So we need to multiply by both of those. I'm going to make this smaller so I have some more room here. Guess that's not going to work. Okay, we'll just. Okay, so you need to make sure that you have all of the factors down there covered for the least common multiple. So we need to have the x minus 5. And we need to have the x minus 4. Okay, this one just needs an x minus 4, which we already have taken care of, and this one already has both of them. So if we multiply by this into all pieces, it will cancel out all of those denominators, which is what we want. So I'm going to, again, write down this original part first here. And then we want to multiply in this least common multiple. Okay, so we're going to multiply this into every term. So I'm just going to take it and copy it. So we're going to multiply this into the first part. Okay, we're going to take this and multiply it into the next one. Okay, and then we're going to multiply it into this final one. So distributing it to all three of those. So I just multiplied it here, here, and here. So now we'll go through and simplify. So see anything that cancels out. So nothing simplifies here. So we're left with x minus 5 times x minus 4 plus over here, x minus 5 cancels with x minus 5. So we have 7 times x minus 4. And then over here, the x minus 5 and the x minus 4 cancel, and we're left with just 7. So now we need to simplify this out to combine and solve. So we've got two binomials multiplied here, so we'll FOIL this. You can put it in the box if you want to. So x times x is x squared. X times negative 4 is negative 4x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is plus 20. Okay, so that's that part. Then we need to distribute this 7 in. So we get 7x minus 28 equals 7. So now go ahead and combine your like terms over here on the left side. So we've got the x squared. We've got negative 4x, negative 5x, which is negative 9x, plus 7x. So that's negative 2x. And then we have a positive 20 and a negative 28, so that's minus 8. And then equals 7. A quadratic again, so we're going to need to get everything to the left. Well, to one side, I'm going to bring it to the left. So subtract 7 from both sides, so you end up with negative 15. Then you can factor. Okay, so what are the factors of negative 15 that add to negative 2? So that's going to be negative 5 and positive 3. Then we can split these and set them equal to 0. So x minus 5 equals 0 and x plus 3 equals 0. Add 5 to both sides. Subtract 3 from both sides. And these are your two solutions, 5 and negative 3. So let's go up to the original problem, okay, and see if either of those, so we got x equals 5 and x equals negative 3. So do either of those make the denominator 0? So if I plug 5 in here, that's going to make this 0. So this one is extraneous. But I could plug negative 3 into all of them and it would be fine. So the answer to this one is just negative 3.